Hey everybody, I'm Silas, and welcome to Psilocybology. Let's expand our mind. This is a series where we talk about the research on psilocybin, the psychedelic prodrug found in magic mushrooms. We'll be breaking down and discussing the scientific literature, one study at a time, from past to present. If you'd like to support the show, please rate and review the podcast wherever you can, and be sure to share the podcast with anyone you know who might enjoy the content. I really appreciate it. Today's episode is on the article titled The Effect of Psilocybin Upon the Systemic, Pulmonary, and Coronary Circulation of the Intact Dog, published in 1962. The idea behind this study is that the researchers noticed a current gap in the existing literature, namely that a detailed study has not examined the effects of psilocybin on the circulatory system. Now, the circulatory system is often thought of as having two major components, what's called systemic circulation and pulmonary circulation. Systemic circulation transports oxygenated blood away from the heart to the rest of the body and returns deoxygenated blood back to the heart. Pulmonary circulation takes the deoxygenated blood that has been returned to the heart and carries it to the lungs. It then brings the newly oxygenated blood back to the heart, where it can re-enter into systemic circulation. As you can see, the heart plays a role in both systemic and pulmonary circulation. If we were just looking at the circulation of blood in the blood vessels that supply the heart muscles, then we would be examining what's called coronary circulation. If you'd like to see diagrams of these systems, they'll be included in the episode transcript, which you can find on the website psilocybology.org. So in order to get a detailed study of how psilocybin affects the circulatory system, the researchers chose to use 8 dogs that were put under using morphine sulfate and diurethane nembutal. Cardiac catheters were then placed in the pulmonary artery and coronary sinus, and a cornon needle was placed in the femoral artery. The researchers took baseline measures of their outcomes of interest, and 20 minutes later administered 0.5 milligrams psilocybin per kilograms body weight, intravenously. At the end of the experiment, the dogs were killed and the hearts were removed for further analysis. Immediately post-administration, there was an increase in both systemic and pulmonary arterial pressure. In particular, mean femoral pressure increased by 17%, and the mean pulmonary artery pressure increased by 32%. The femoral artery is a large artery that provides blood to the leg and is part of the systemic circulatory system. They also saw an increase in both systemic and pulmonary vascular resistance, which is a measure of how much resistance must be overcome in order to push blood through the circulatory system. Interestingly, the researchers also observed a decrease in cardiac output, which is the volume of blood that is pumped by the heart per unit time. Cardiac output is calculated simply as the heart rate multiplied by the stroke volume, or the volume of blood pumped from the ventricle per heartbeat. I say this finding is interesting because after administering psilocybin, they found a significant rise in heart rate, but a significant decline in stroke volume, which is what is driving the reduced cardiac output. So far, the outcomes we just talked about have been considering pressure work responses. Another set of outcomes the researchers examined are classified as general metabolism, which primarily focuses on measures related to the process of respiration, or breathing. What the researchers found was that the psilocybin caused a decrease in respiratory volume and respiration rate, which is the amount of air displaced between inhalation and exhalation, and the number of breaths taken per minute, respectively. There was also a decrease in the amount of carbon dioxide exhaled, and a decrease in arterial oxygen content. Finally, there was an increase in oxygen extraction, meaning that a greater amount of oxygen was being removed from the blood. The last set of outcomes focus specifically on coronary circulation, or the heart. Although earlier we noted that there was an increase in systemic and pulmonary vascular resistance, there was actually no change to coronary vascular resistance. The cardiac metabolic rate for oxygen, however, did significantly increase. So how do we interpret all of these findings? Well, the researchers end their paper by drawing comparisons between the results seen after being given psilocybin to similar research that has been done to examine the circulatory effects from other drugs. First, they conclude that the increase in systemic and pulmonary pressure is in line with other well-known effects of sympathetic stimulation. Sympathetic stimulation is referring to an increase in activity from the sympathetic nervous system, which is part of our autonomic nervous system responsible for the fight or flight response. By contrast, the parasympathetic nervous system is the part that is responsible for what has been called both the rest and digest as well as the feed and breed response, because it stimulates blood flow to the digestive system and reproductive system. Sympathetic stimulation is a common side effect of many hallucinogens and, of course, stimulants. One thing that differed from other sympathomimetics, which is just a fancy name for drugs that stimulate the sympathetic nervous system, was that there was no change seen in coronary vascular resistance. Now, although we also saw depressed respiratory activity after being given psilocybin, the researchers note that this may actually have been due to the psilocybin enhancing the effects of the anesthesia. They noted that other hallucinogens have in fact been shown to interact with anesthesia, and we've actually seen that in one of the previous episodes, where psilocybin appeared to greatly enhance the effects of barbiturates, used to sedate rats, which ultimately proved to be a fatal combination. The last part of the conclusion I want to touch on is that the authors note that based on the results of this study, psilocybin appears to show some serotonin agonist and serotonin antagonist activity, meaning that in some instances psilocybin acted in a similar way as serotonin, and in other ways it appeared to work against some of the effects of serotonin. Since this is a fairly brief article, I think it is a great opportunity to discuss a brief 2-page report titled Serotonin-like and Anti-Serotonin Properties of Psilocybin and Psilocin, that was published also in 1962. This brief report was a little bit too short to make it its own episode, but I think it feeds in nicely to the discussion here. So if you happen to make it through this far into the episode, congratulations, you get a bonus article. To run down the methods really quick, the researchers of this report essentially applied either serotonin, psilocybin, or psilocin to isolated rat uteri. For context, serotonin has been known to stimulate contractions, and so after applying each drug, they measured the contraction in centimeters. Here's what they found. After applying serotonin, as expected, there was a sharp increase in the size of the contractions, reaching a plateau of about 5 centimeters, after applying a solution of 0.003 micrograms per milliliter to the rat uteri. For psilocybin, they found a steady increase in the size of contractions stimulated, but the slope was not nearly as steep, and even after administering 0.25 micrograms per milliliter to the rat uteri, the contractions only reached about 4 centimeters. Now, psilocin had by far the most interesting effects. Up till 0.03 micrograms per milliliter, there was an increase in the size of contraction, which reached 3 centimeters. What was interesting is that as you increase the dose further, the size of the contractions began to decline. So that was the first half of the experiment, which really just showed that, to some extent, psilocybin and psilocin both act a bit like serotonin. The second half of their experiment co-administered serotonin and psilocybin, or serotonin and psilocin. The goal was to see how much psilocybin and how much psilocin would be required to reduce the size of the contraction produced by serotonin alone. What they saw was that administering 0.03 micrograms of psilocin cut the effects of 0.01 micrograms of serotonin in half, and about 1 microgram of psilocybin cut the effects of serotonin in half. Unexpectedly, they also observed that both psilocybin and psilocin reduced the effect of serotonin on contraction size even after they washed the tissue and reapplied just serotonin alone. The psilocybin and psilocin appeared to cause, quote, an irreversible change in sensitivity to serotonin. So overall, this report really highlights how psilocybin and psilocin both in some cases work similarly to serotonin, and in some cases appear to act as serotonin antagonists. To wrap up this episode back with the article we started with, the researchers summed up their study in 2 sentences that I think are really simple and well stated. Quote, in the circumstances of our experiment, it would seem that psilocybin depressed respiratory activity, oxygen saturation, and cardiac output. it would be unwise to extrapolate to the unanesthetized human. Well, that's it for today's episode. Before I go, I just want to mention again that if you're enjoying the podcast, please do rate and review the show. Seeing people rate and review the podcast really does give me a sense of value that can't be understated. To quote Albert Camus, "An individual must be acknowledged by other individuals. All consciousness is, basically, the desire to be recognized and proclaimed as such by other consciousnesses. It is others who beget us. Only in association do we receive a human value." As always, I really hope you enjoyed the show. If you have any questions, feedback, or ideas for the podcast, please let me know. You can find out all of the ways to reach me on the website, psilocybology.org, where you can also find the full transcript for each episode if interested. Thank you all so much for listening, and I'll talk to you next time.